Hello, I'm your host, Khari Douglas, and welcome to Catalyzing Computing, the official podcast of the Computing Community Consortium. The Computing Community Consortium, or CCC for short, is a programmatic committee of the Computing Research Association. The mission of the CCC is to catalyze the computing research community and enable the pursuit of innovative, high-impact research. In this episode of Catalyzing Computing, I sit down with Vint Cerf during the Heidelberg Laureate Forum in Heidelberg, Germany. Widely known as the father of the internet, Cerf is the co-designer of the TCP/IP protocols and the architecture of the internet. Cerf began his work at the United States Department of Defense Advanced Research Projects Agency, or DARPA, playing a key role in leading the development of internet and internet-related data packet and security technologies. In December 1997, President Bill Clinton presented the U.S. National Medal of Technology to Cerf and his colleague, Robert E. Kahn, for founding and developing the internet. In 2004, Cerf was the recipient of the ACM A.M. Turing Award, and in 2005, he was given the Presidential Medal of Freedom by President George W. Bush. Since 2005, he has served as Vice President and Chief Internet Evangelist for Google. In this role, he is responsible for identifying new enabling technologies to support the development of advanced internet-based products and services. He is also an active public face for Google in the internet world. The Heidelberg Laureate Forum, or HLF, is a networking conference where 200 carefully selected young researchers in mathematics and computer science spend a week interacting with the laureates of the disciplines, recipients of the Abel Prize, ACM A.M. Turing Award, ACM Prize in Computing, Fields Medal, and Nevelina Prize. Established in 2013, the HLF is annually organized by the Heidelberg Laureate Forum Foundation. You're listening to the Catalyzing Computing podcast here at the Heidelberg Laureate Forum, sitting down with Laureate Vint Cerf. How are you doing today?
Well, right now I'm enjoying the somewhat wet weather here in Heidelberg, but what's exciting is all the people who are here sharing ideas, and that's all on fire.
So could you just say a little bit about where you grew up and how you got involved with computer science?
So I grew up in Southern California, north of Los Angeles, in an area called the San Fernando Valley. That's where I did my high school work, and I got interested in computing around 1958. I was introduced to a system called the Semi-Automated Ground Environment, which used a tube-based machine to process radar information coming from northern Canada, trying to see Russian bombers coming over the North Pole, because those were the years of the Cold War and everybody was worried about the U.S. and the Soviet Union. And then later, that was 58. By 1960, my best friend and I got access to computers at UCLA, and we were able to learn to program. So my interest was piqued fairly early relative to my life. Most kids today get access to computers when they're 2 years old, so They're way ahead of me. I went to Stanford University to major in mathematics, but I took every computer class I could, and then I went to work for IBM for 2 years, realizing that after working for 2 years at IBM that I needed to know a lot more about operating system design, compilers, languages, data structures, and things like that, and did a PhD at UCLA in the computer science department, and then went up to Stanford University to join the electrical engineering and the computer science faculty with half of a position in each one. So my interest in computer science was really from about age 15 to the present. Wow. And it continues today.
Yeah. So you're known as one of the fathers of the internet, and there's a ton of content out there about the whole creation of that, so we won't go into that here, but I want to get your thoughts sort of on the future of the internet. A big issue that's come up lately is net neutrality. So what are your thoughts on that, and how do you see that issue going forward?
So the term net neutrality is not always interpreted the same way everywhere, and people who would like not to be told what to do will try to make net neutrality a bad thing. In the United States, the reason that net neutrality came up at all is that there was not very much choice for consumers of internet access. Sometimes in the rural part of the country, they had no choice at all. In the suburbs, you might have one choice of carrier. It could be a telecom company. It could be a cable carrier, for example. Increasingly, the mobile services are providing internet access, so that's a third alternative. But sometimes you don't have a choice of more than one or two. In the middle of the city, sometimes you have a choice of two or three. But because 2 or 3 doesn't really represent a great deal of competition, you don't have a market which is disciplined by competition. And so there was a pretty significant and long-lived debate about what restraint there should be on the way in which the providers of internet service behaved. And in particular, there was concern that they might constrain users' ability to get anywhere on the internet they wanted to go, or that they might detect that the user was using somebody else's video services and interfere with the quality in order to force them back to their own vertical products. So these kinds of anti-competitive behaviors were essentially banned under the net neutrality rules adopted by the Federal Communications Commission. The current administration undid that. And basically said, well, we don't want to interfere with the free operation of the internet providers. Translation, it's okay if they interfere with the customers. So I still believe that net neutrality is an important concept to the extent that it inhibits anti-competitive behavior and assures a level and competitive playing field. The situations in other parts of the world may vary. In some cases, for example, there's structural separation. There's an underlying wholesale service which all the retailers have equal access to. Mm-hmm. The provider of the wholesale service doesn't interfere with the retailer's operation. And the retailers, of course, can do whatever they want to do, and the customers will walk from one to the other depending on what it is they want. We have a worked example of this in Kampala, Uganda. Google put in a fiber network as a wholesale service, and then they offer that on equal terms to the retailers, and the retailers offer a variety of services to the customers. So I still think that we want to inhibit anti-competitive behaviors and encourage choice for consumers, and whatever rules will produce that outcome, I think is good for everybody, including the internet.
So do you think that's mostly a policy question, or is it also technical?
It's essentially a policy question. Some people treated it as if it were a technical question because people were doing deep packet inspection to say, oh, they're doing streaming video, let's interfere. More and more now we're seeing cryptography from the user all the way to the server or to the cloud, in which case deep packet inspection is less effective and so therefore less of a problem.
So another topic related to the internet, sort of a problem, I guess, that's cropped up is spoofing. Someone sends you a link to a website. It looks like bankofamerica.com, but one of the characters is different. Takes you to a fake website, you enter your info, and it gets stolen. What do you think can be done to sort of prevent that or limit that going forward?
There are a number of different kinds of spoofing that go on. At the core of the network, we actually have some serious problems. Even the routing system, for example, somebody can announce that they are connected to certain parts of the internet and you should send traffic to them, even though they aren't. And so this is misrouting occurs. We're working hard in the technical level to use digital signatures as a way of authenticating the routing announcements to avoid that kind of spoofing. There's the invasion of the domain name system. Some of the domain name servers are vulnerable to malware attack. And a domain name like www.deutschebank.de might be mapped to the wrong internet address. Because someone got into the domain name server and changed the numbers, that means you couldn't tell that you were going to the wrong place. And if they have scraped the screens of Deutsche Bank, it looks like Deutsche Bank, and you log in and you lose your credentials. So as I say, you are quite right. There are a lot of different kinds of spoofing that can happen. In the particular case you were describing where you went to the wrong website and you offered the wrong credentials. One mechanism for avoiding this kind of attack is to use two-factor authentication. And what that often means is that you have something that you, in addition to your laptop or tablet, you have a cryptographic device and it has a key in it. And only the legitimate bank has the matching key on the other end. And the result is that when you're challenged to provide your cryptographic credential, the bank that is spoofing won't be able to figure out what the right answers are, whereas the legitimate bank will. And so the two-factor authentication makes it harder for somebody to spoof because they don't have the information that the legitimate bank has. So this works in both directions, identifying the user and identifying the bank. Digital signatures on the domain name system can also help because it makes it impossible for somebody to change the domain name mapping to IP address because they won't be able to put the correct digital signature on it. As a result, when you receive a response back and you check the digital signature, it's not right. And then you know that you shouldn't go there because it's been spoofed. So there's a lot that we can do on the technical side. We also need to educate people to be suspicious about what they're seeing. Look for domain names that have been spoofed, like the letter O has been replaced by a 0, and you don't notice that, so you go to the wrong place. People need to learn what risks there might be in the online environment. Generally, we can call that digital literacy. And just like you take tests before you can drive a car. I don't think we need an internet driver's license exactly, but people should be taught about what the risks and hazards are and how to avoid them before they get online and use the net.
Right. You mentioned two-factor authentication. I've heard of some issues in terms of scammers being able to get phone numbers changed to be their number. Do you see any ways around that?
I can speak to that. What happens if the two-factor authentication is done by using the mobile phone, and the idea being you have a phone and a newly generated pass number, like 6-digit number, is sent to the mobile phone in addition to your username and password interaction on, let's say, your laptop. That second factor is supposed to help, except that it's possible to clone the phone. And there are reasons for that perhaps could be dealt with. But I prefer two-factor authentication that involves a physical piece of equipment. We sell those at Google and urge people to use them so that it's a cryptographic device which is not online. You plug it into your computer, but you don't radiate anything, and it's not sitting in a device that can be attacked in the way that the mobile phone can. So those are called hard factors or hard second factor authentication. And I think those are more effective. Now, there is a problem because if you have 100 different accounts, you wouldn't necessarily want a bag full of 100 of these little hardware devices. Right. So now the question is, how do I design a device that can hold hundreds of keys but still be one physical device? This is quite feasible to do, and I'm surprised that we haven't seen more use of that kind of design. But I think we should continue to encourage people and the servers, the various websites, to encourage all of their users to adopt these kinds of technologies.
Well, perhaps that'll be the future. So where do you see IoT development going over the next few years? And earlier in your press conference, you mentioned sort of technology helping people with disabilities or augmenting human capabilities. Do you have any thoughts on how IoT could help do that?
Sure. Well, first of all, we can certainly see a great deal of energy going into what is called the Internet of Things, lots of devices with software in them and connections to the Internet. Some of the most visible manifestations of that are devices that can be managed by voice interaction. In the case of Google, it's with an assistant, a piece of software that understands speech and knows about devices that you have in your home or your office or your car or on your person, and can interact with those devices on your behalf. So I see two things going on there. One of them is the tremendous potential benefit of being able to interact with this collection of devices and get the lights turned off and on, and the oven turned off or on, or the heating and ventilation system set properly. Or even if you're away from home, you want to just make sure everything is okay. You can ask, has anything changed? The problem I run into, though, is that the software has to be reliable. It has to protect your privacy. It has to be safe to use. It has to defend itself against various kinds of attack. And so the big worry I have with IoT is that the people that make the devices may not spend enough time making sure those devices are safe and reliable and resist attack. And that might be because they're not charging very much for the device. Maybe it's a $100 device. Maybe it's a $10 device. How much time are you going to spend on security? So we need to get standard practices and widely available and strong operating systems. We'd like to think Android, for example, satisfies some of that requirement, and we make that widely available. But that's going to be an important part of IoT, and that's getting people to take responsibility for safety, security, and reliability. With regard to people with disabilities, these programmable devices, in theory, have a great deal of flexibility. And so you would hope that with proper programming, they can adapt well to some of the assistive needs that people have. Nonetheless, it's a big challenge, partly because the people writing the software don't always have an intuition about what would make a good assistive response. So sometimes the understanding of disability is only on the extreme sides, like complete blindness as opposed to some partial vision, or I just need to blow the letters up because I can't see them when they're too small. Or in my case, I wear hearing aids. I need the volume turned up, otherwise I can't hear it. Some people who are totally deaf need to have readable or visible signals instead of audible ones. And people with motor disabilities who can't control a mouse, for example, or a pointer, a cursor, need help with that. Those sorts of things don't always come to the mind of the people designing software, or they design the software for the normal case, and then they try to add features for someone with disabilities. Often it doesn't work very well, as opposed to thinking about the design in the context of a disability and then making sure you put the right features in to handle that. That's not going to be solved until we have more programmers with deep understanding of the nature of disability and the way in which we can respond to it to accommodate.
Right.
And so that means we should be teaching classes in design, accessibility by design, usability by design. There isn't enough of that. And I keep poking the university saying you're missing an opportunity here.
Hopefully we'll see more of that. So another thing that you sort of talked about during your press conference, but I didn't get a chance to ask you, and maybe this is outside of your scope, but you mentioned there are now a lot more satellites going up, undersea cables to provide internet, and as we're talking about, there's more internet-connected devices. Do you see any concerns from an ecological perspective in terms of these added devices and products existing?
So, yes, I mean, there are a number of things that we might be worried about. For example, the data centers consume a lot of electricity. It's not as much as some people think, but it's still a lot. And one of our objectives at Google when we build data centers is to reduce as much as possible the power requirement by getting more clever designs of hardware. But we're also now fully committed to renewable resources. And as far as I understand, we just made the largest purchase of renewable resource for the next 30 years of any organization in the world. So we're very much committed to orienting our company around a renewable future. There are other ecological issues arising, though. In the case of satellites, the proposals now coming from a number of companies is to put several 10 or 20,000 satellites in orbit. There are only about 6,000 or 7,000 in orbit now. You add another 20 and you have a fairly crowded sky. I worry about some of them running into each other. I worry about them falling out of the sky. I worry about the unexpected side effect for the optical astronomers when they start seeing streaks in their pictures because satellites are going by in the field of view. Or maybe there's radio interference for the radio telescope people. So that's less ecological than it is interfering with somebody else's interests. In terms of undersea cables, there is a substantial amount of continued growth of the cable system. It's becoming less expensive to build cable. Google has actually built some of its own cables now. We didn't actually build the cable, but we paid for them alone as opposed to in partnership. So that's becoming extremely popular. The big worry about undersea cable is not that it causes ecological damage, because I don't think it really does. Even the cable landings are not necessarily that harmful. But the problem is when we become very dependent on the communications capability and some ship comes along and breaks the cable, which happens more often than we would like, dragging an anchor. That's a different problem. That's now becoming deeply dependent on a particular technology and then having it go away. And the question is, what do you do now? I mean, when the internet goes away, you quickly understand how dependent you might be on it, your mobile in particular, which is overloaded with applications. If you're out of reach of the 4G or 5G or whatever signal, or you can't get to a Wi-Fi system, then the mobile doesn't do what you wanted it to do, and suddenly you don't have any backup, and then you have a problem. So the more we depend on complex technology, the more risky it is when something goes wrong. And I do worry about that. I think we should be thinking about, how do I back this stuff up? What do I do if all the power goes out for 5 days? What do I do? Do I have a backup for that?
So you're also involved in a project with NASA and the Jet Propulsion Lab to develop interplanetary internet. Can you say a little bit about the challenges to building that and what benefits that kind of system would provide?
So there have been several. One of them is just the design of the protocols that will operate across a much wider regime than TCP/IP. So in this case, we need to deal with highly varied delay or latency environments. So we're talking minutes to hours to days of latency as opposed to a few hundred milliseconds. So the TCP/IP protocols that animate the internet don't work, between here and Mars. So we had to develop a whole new suite of protocols, which we have done. We being NASA, the Jet Propulsion Lab, the European Space Agency, the Japanese Space Agency, the Korean Space Agency, all of them are participating in standardizing the interplanetary protocols. And we made a lot of progress on that. They're now running in the International Space Station, so we've had interactions between Earth and the space station. The astronauts are using these protocols. We also have prototype software that's been running on Mars since 2004, so we have some experience with those those prototype systems. Most of the data that's coming back from Mars has come from those prototype interplanetary protocols. So standardization has moved well. There is a commitment now among the space agencies to use these protocols on missions following 2020. And there are two motivations for that. One of them is it confers interoperability across multiple spacecraft from different space agencies. And second, it might be possible to repurpose some of those spacecraft to become nodes of an interplanetary backbone. So over time, as missions get launched, we may be able to grow the backbone to support future missions. So this is an important concept because it's a multi-mission kind of infrastructure. I'm very excited about the Return to the Moon Gateway program at NASA, which is intended to make use of the interplanetary protocols again in anticipation of missions to Mars. So the hard part, I think, has been getting everybody to accept the standards and then to implement them and make them the norm. We're still sort of part of the way there. One other thing that very excited me is that we did a test using a laser bounce off the moon, and so we were able to show the protocols worked at 600 megabits a second.
Wow.
If we ever get optical lasers for communications for deep space as opposed to radio, then we'll be able to support the much higher data rates. The kinds of elaborate equipment that are being sent to the outer planets is, in fact, demanding an increasing amount of data to come back. And so optical may turn out to be helpful, and our interplanetary protocols now know that they can handle that.
That's exciting. So before we wrap up, can you just say a little bit about what participating in HLF has meant to you over the years?
So this is the 7th Heidelberg Laureate Forum. I've been to almost all of them. I think I missed at least one. But there are several things that I like about coming here to Heidelberg. First of all, Heidelberg is a great place to be, especially when it's not raining, which unfortunately later in the fall tends to happen. On the other hand, it has this wonderful long history of intellectual stimulus. It has a university, and surrounding Heidelberg are a number of very high-tech companies, the European Molecular Biology Lab, SAP, and then an adjacent town, for example. So I enjoy returning to visit those places. I had a chance to visit one of the high schools yesterday. And again, meeting young children who are all full of energy and lots of questions is great. Meeting the new students every year, there are 200 of them, 100 math and 100 computer science. That's always very invigorating because they bring new ideas and new challenges to the conversation. And I get to meet old friends here and meet some new ones because as we acquire new laureates from the mathematics and the computer science area, they get to come to the forum as well. So it's really a pleasure to see some of these people because I only see them in Heidelberg. So from my point of view, it's always a stimulating week. It's an intense but very stimulating week. And then I get a chance to talk to people like you, and it's an opportunity to share some of that enthusiasm with your listeners.
Yeah, this has been great. Thanks for taking the time to sit down with me. I guess I'll see you at Bavaria night later today.
Well, you know how this goes. I'll see you on the net.
That's it for today's podcast. I hope you enjoyed it. We'll be back soon with new episodes. Until then, like, subscribe, and rate us 5 stars on iTunes. If you have any questions for former guests of the show, write us a letter at cccpodcastletters@cra.org, and we'll try and get them to answer it. Until next time, peace.